All right. Hey, how's it going, you guys? I noticed that our professor isn't going to post his solutions to the practice exams, so I'm going to do my best to do mine. Usually Steven posts his, but I guess he's not, so I'm going to just do my best. So bear with me if it's pretty bad. All right, so we're going to start with practice exam number 5, version A. So for 5.1, and I'm sorry if my handwriting is pretty terrible too. It says find your f of x, your f of y, your f of xx, your f of xy, and your f of yy, and your f of yx. All right. So to do this, it's actually not that bad. To find your f of x is going to be your partial derivative of your, and this thing right here is my way of saying partial. I don't know how to actually write it. Your partial derivative of your x. And so that means you're just going to take the derivative of the given equation. You can see in the top, it gives us the equation. The equation is x ln of y plus yex. And all you're doing here is just taking the derivative of x for each one. So this will just be ln of y plus ex. And you can see in the, oops, sorry, that's supposed to be just yex, because when you take the derivative of an exponent, it just stays the same. So it's just going to be yex. So in the answer, it says ln of y plus yex. So all you're doing for f of x is just taking the derivative of your original equation that was given. Your f of y is the same idea. You're just taking a partial derivative of your y, and it's going to be d of dy. Like, I don't really know how he wants you to answer this, so this is my method of doing it. I know he wants you to do it as his method, but I'm pretty sure this is his method. So hopefully he doesn't take any points off. And in this situation, now we're just taking the derivative of y in this case. So your x will stay the same, and the ln of y will just be 1 over y. So this is going to be x over y, yes. And then you take the derivative of your yex, so the derivative of y is just going to be 1, and then ex stays the same, nothing changes. You're actually doing the chain rule, or no, product rule, I'm sorry. So you take the derivative of your y, that becomes 1, and that stays the same. And then you take the derivative of your ex with respect to y, and that becomes 0. So that's why you don't see that in there. It's just yex. So that's your answer for f of y. Your f of xx, all you're doing for this one is you're going to use what you found here. You're going to use what you found here for your f of x, which is ln of y plus yex, and you're just going to find a derivative of that. So the derivative with respect to x of whatever you found for f of x. So it's going to be ln of y plus yex. And we notice that from doing this, we take the derivative of ln of y with respect to x. That becomes 0 because there's no x value in there. So that becomes 0 plus, and remember, when you take this, this becomes yex because the derivative of ex is just itself. So it'll just be yex. So that's why when you see it in the answer sheet, it's just yex. All right, I'm going to clear this board, but hopefully you get the gist of it. Actually, let me see. Can I erase this better? No? Yeah, I'm just going to clear it. So we saw for your f of x, your f of y, and your f of xx. Now we're going to find your f of xy now. Or yy, I'm sorry. So f of yy right here. Let's draw it. Oh my god. Okay, f of yy. We said before we erased, your f of y is, so we're going to take your derivative with respect to y of your f of y. And we saw the f of y. Our f of y was, if you look back, it was x of y plus ex. So when you take the derivative of this, right, you know that if you take the derivative of the ex, that'll just become 0 because there's no y value in there. But here, to take the derivative of your x over y, you're going to have to, based on algebra and calculus, it's kind of hard to explain, but you move your y to the numerator, so that becomes y to the negative 1 power. Then that you take the derivative of that, so you move the negative there, and 1 minus -1 would be -2. So it'll be y to the -2 power, and then to make it positive, you just move it back down. So I know this, I'm just verbally explaining it. It just takes a lot of time for me to do it. So hopefully you kind of understand how to do the geometry, or I'm sorry, the calculus aspect of this. But yeah, it will just be -x over y squared. And that's what your f of y is. So now all we got to do is just solve for your f of xy and your f of yx. So now we're going to do f of xy first. Your f of xy is basically asking you to take the derivative of your f of x with respect to y. So it's going to look like this. dy, the derivative of y, and you're going to choose what your f of x was. Our f of x was ln of y plus y e x. All right, so hopefully you guys understand this. That y right here is going to be your derivative value. You're going to take the derivative with respect to y, and then your x value is just going to be what you had for f of x. And it's going to be the same thing for f of yx, but I'll explain that later. So we're going to find this with respect to y. So ln of y, derivative of y, will just be 1 over y, okay? And then the derivative of y ex with respect to y will just be e of x. So that's what you get for f of x, y. This is your f of x, y right here. Let me just write it right here, f of x, y. Now your f of yx, like I said before, it's going to be your derivative with respect to x this time. Like we said, now it's going to be with respect to x of your f of y value. And from previous work, we said our f of y value is going to be x over y. Sorry, I just had to read through my stuff, of e of x, right? And when we do this, is this going to become 1 over y plus e of x. It just stays the same. So here, and when he asks you to clarify this using Clarence theorem is basically saying you have to find your f of xy and your f of yx, and then see if they're equal to each other. As you can see, both of these are equal to each other, the 1 over y plus ex and 1 over y plus ex. That means that Clarence theorem passes this, or this passes the Clarence theorem. So that's 5.1. Hopefully that was pretty straightforward. Let's go towards 5.2 now. 5.2 is actually pretty easy. So it's just asking for each direction indicated below, find the slope of the tangent line, or the line tangent to the surface, defined by z equals f of xy at the xyz point. And it gives us the surface of 0, 1, 1. So for 5.2a, it's asking us to, in the positive x direction, that is the plane is y equals 1, find the tangent slope, or line tangent to that. So all we're doing here is we're using the f of x value because it's asking us to find it in the positive x direction. So your f of x value with the points is 0, 1. The reason why we're using 0, 1 is because that's the x and y points. This is a 2D plane, so the 3D value of z is not considered in this equation. So it's just your x and y values, which is x is 0 and your y is 1. And you can see it in the question, 0, 1, 1. Ours x is 0, y is 1, and our z is 1. But since this is a 2D value or 2D plane, we disregard z. All right. And basically all you're doing here is just whatever you saw for f of x, and as you can see, f of x was the ln of y plus y ex, all you're doing is just plugging those values in. So ln of y, which is ln of 0 because, oops, sorry, that is ln of 1, right? Because our y is 1, plus the y e of x. Y is 1, e, and our x value is 0. Okay, so your ln of 1 will always be 0. That's based on algebra, common algebra. Ln of 1 will be 0. And e to the 0 power, anything to the 0 power will just be 1. So plus 1. And so that's how we got a, for part A, is just 1. Now for B, it's same thing, but now you're doing for the y value, for f of y. So f of y, still using the same points, 0 and 1, it's going to be, what is our y value? Our f of y was x over y plus e of x. So remember our x is 0 over y, which is 1, plus e of x, e to the 0 power. And solving this, we know that 0 in the numerator will always be 0 in total, plus e to the 0 power. And like we said, anything to the 0 power is 1. So that's how we got b is 1 as well. So that's your answers for 5.2. It's actually very straightforward. It seems, at first when I saw this too, it seems pretty scary, but it's not that bad. All right, so that's 5.2. Moving on to 5.3. 5.3 is possibly the longest one out of all of these questions given. 5.4 and 5.5 are just simple plug and play. It's actually not that hard. All right, I'm gonna erase this. Hopefully y'all see. Hopefully y'all can pause this so y'all can see for yourselves. All right, 5.3. So let's start with 5.3. Like I said, I apologize if my handwriting is bad. I'm using a mouse to do this, and you probably can hear my mouse in the background. But let's just ignore that. So reading from 5.3, I'm just gonna write whatever is given to us. So whatever is given is our z equals x squared plus xy plus y squared. Okay, that's given to us, and it was also given of x equals sine of t and y equals cosine of 2t. Cosine of 2t. Just keep in mind, you know what, I'm just gonna, god damn it. Oh wow, that's actually how it works. Interesting. Okay, cosine of 2t. I'm using Microsoft Zoom to like record this, so this is kind of weird. All right, so we're given these three values, the z, your x, and your y. The chain rule equation is dz, because right in the question is asking us to solve for dz over dt. To solve for dz over dt, the equation will be the partial derivative of your z of x. This is the partial derivative. I'm sorry, this is what my partial derivative symbol looks like, times your derivative of x over dt. Your derivative of x over dt, keep in mind. And then plus your partial derivative of your y this time, your partial derivative of z over y. And this time, this is going to be your derivative of y over dt. Keep in mind that these two are not the same. This is the partial derivative, and this is just a regular d. Like I said, I apologize if my handwriting is terrible. I'm doing my best to make this clear. So just bear with me. All right, so this is just our equation. And like what Mr. Professor Noring said, this is a simple plug and play. And the reason why this is simple plug and play is this: we got to find our values of the partial derivatives, and our derivatives itself. So let's find, what did I do here first? Let's find the partial derivative of our x first. So this equation right here, or this value right here, okay? All you're doing is you're just finding the derivative of your x of the original z equation, which is this right here. So it's gonna be x squared plus xy plus y squared, okay? And that's gonna be easily or simply 2x plus y. Why? Because x squared will just be 2x plus xy will just be y, and there's no x values here, so this will just be 0. So that's your partial derivative of your x value. Now let's do it for the y value, z of y. Okay, so that's supposed to be a y, so just keep that in mind. And the same thing, you're finding the y values from your original z equation that was given to us. And this becomes, remember that there's no y value here, this becomes 0. This becomes x because there's a y there. And this becomes 2y. All right, so we have our partial values for our x right here and our y value right there. Oh my goodness, that looks terrible. But I'm just gonna, now you know that. Now you know that. All right. Now we're gonna find our derivative values of x and t. And how do we do that? Pretty simple. We're just finding the derivative of this and the derivative of this. So d of dx or dx of dt of your sine of t. What is it? So the derivative of sine is just cosine of t. So d of dx, d of dx. I'm gonna keep this PG. Let me just simply erase that. All right. So yeah. You get me. You know. So d of dx, that's supposed to be d. Wow. All right, let me do this one more time. D of dx, right? Your derivative of your sine of t. Okay. Your dx of dt will then equal, what's the derivative of sine? It's just cosine of t. And then now let's look at d of dy of d of dt, or your derivative of y with respect to t. So d of dy, I'm sorry, that's supposed to, This is not supposed to say the derivative of x. This is supposed to say the derivative with respect to t. d dt. d dt, and this is also to say d dt. All right, so d dt, okay, times your cosine of 2t. And what is that? So this is going to require a chain rule. So first you have to take the 2 out. So the 2 will go outside. And then you find the derivative of your cosine, which will be negative sine. So it's going to be negative 2 sine of 2t. And that's all based on chain rules. So now we have 4 values. We have 4 values that we found. Let me use a green. We have your partial derivative of x, your partial derivative of y. We have your dx of dt, or your derivative of x, and then you have your derivative of y. So we have now, we have all 4 values, this one, this one, this one, and this one. All we got to do now is just plug and play. So I'm gonna erase this. Can I copy this actually? Probably not, but let me just clear this. All right. So hopefully you remember that equation of, oh, no, I'm good. All right, so d dt equals your partial derivative of z of x. So that's just saying your partial derivative of x of dx dt, your derivative of your derivative of x, and then here's your partial derivative of y. Okay, and then your derivative of y. Yep, everything's right. And all you're doing is just plugging in the values that we solved, and by doing this we get, keep in mind, all I'm doing right now is just plugging in. So if you're confused of where I'm getting the numbers, just look back and see what each one equals to. So 2x plus y is this right here. Your dx of dt was just easily cosine of t, right? Okay, plus, now what's the partial derivative of y? We said it was x plus 2y. This is for the partial derivative of y, times, what is the derivative of y? We said it was negative 2 sine of 2t. Okay. And all I did here was I basically simplified this, but what the answer is saying is that they don't want you to have any x or y values in this equation. So going back to that earlier given value, we had x is sine of t, and your y is cosine of 2t. Okay, keep in mind, these are 2 given values. I'm going to quickly not simplify this. What I'm going to do here is I'm going to plug in those values of x and y into wherever there's an x and y value. So you see there's an x here, y here, x here, y here, and that's it. So I'm going to do here, what I'm going to do here is I'm going to say 2, what's x? Sine of t. I hope you know what I'm doing right here. All I'm doing is just plugging in what the x is. X is sine of t. And this is an original value that was given to us in the question. Plus y. What is our y? Is cosine of 2t. And this is all multiplied by cosine of t right here. All multiplied by cosine of t plus, okay, now let's look at this side. What is our x again? Remember, x is the sine of t plus 2 times the cosine of 2t. This is our y value, okay? And this is all multiplied with negative 2 sine of 2t. Okay, so basically we're done, but we just want to make it to where it looks like Professor Noring's writing. So this side is good. This right side is basically good. It looks exactly what's written in Dr. Noring's writing. This right side, however, all he did was, so let me just quickly write the final answer. So dz of dt will equal your 2 sine of t plus cosine of 2t, okay, times cosine of t. So that's your left value. You see right there. Plus, now doing this right side, all he did here was just basically, actually it's not plus, it's just going to be minus. Reason why is this, let me just explain it. So all he did was just, he kept the sine of 2t out. All he did was just multiply this negative 2t for both of these things right here. So it's going to be minus. He moved the 2 cosine 2t first, but it doesn't matter which one you put, it still ends the same way. So it'll just be 2 sine of t plus 4 cosine of 2t. Okay, all multiplied by sine of 2t. And you might be wondering, why is this positive? Is because there's a negative sign here, right? If I did a positive sign here, then I'll just do negative here and then negative here instead of the x value. But in this situation, I just moved the negative values outside the brackets. So then this just becomes positive, and this is just becomes, I'm sorry, that becomes negative. I'm sorry, I'm stupid. That becomes negative and that becomes positive. Because if you do distribution, that'll become negative 2 sine of t minus 4 cosine of 2t. So it's the same idea. So that's the answer. That's the answer for what number? This is 5.3. Pretty simple. It's actually not that bad. It looks very intimidating at first, but once you work it out, it's actually pretty cool. That's what Professor Norm would always say to us. And make fun of us for being stupid. All right, 5.4. All right, let's get it. 5.4 is, I guess, I think this is probably the easiest one, 5.4. Let us see. So it gives us the equation of x cubed plus times y plus x y cubed equals 3. It gives us that equation. What I'm going to do real quick is move that 3 to the left. So I'm going to do y. So then minus 3 equals 0. So now we have an equation right here. To find the implicit differentiation, it's asking us to find dy of dx, okay? When you're finding implicit differentiation, the equation of dy of dx, wow, that thing is really out there, isn't it? All right, so dy dx, okay, is negative f of x over f of y. This is an equation in the book. I'm pretty sure he worked this out in class, but I really don't look at his class. I just log in and just head out. I'm just there for the extra credit. But yeah, this is the equation for a differential, implicit differentiation. That's the equation. And like we did for 5.1, we have to find your f of x and your f of y. And how we do that is pretty simple. So remember, your f of x is the same thing as this. It's just lowercase. If you want me to do capital F of x, I guess I'll do that too, just to make it pretty organized, or like those who have OCD or something like that. All right, so f of x, all you're doing right here is just taking the derivative of x with respect to that equation that we just solved right here, right above us, right here. So it's going to be x cubed y plus xy cubed minus 3. What's the derivative of this equation with respect to x? It will be 3x squared y plus y cubed, and that will be 0 because it's a constant. So that's your f of x. Now let's look at f of y. You're going to do that same thing, but now with respect to y, do the original drawing or original equation, y cubed minus 3. Okay, so this just becomes x3 because there's a y here, and that just becomes 1. This becomes 3xy squared, and that also becomes 0 because there's a constant value. There's no x or y values there. All right, so this is that. This is that right here. This is your f of x, and this is your f of y. And all we're doing now is just plugging and playing. So your d of y, d of x is just going to be your negative value, because this is what we have here, negative, of your f of x over f of y. Your f of x, like we said, is 3x squared y plus y cubed. Your f of y value is x cubed plus 3x squared. No, I'm sorry, just 3x y. So there you have it. There is the answer for, my goodness gracious. This is the answer for dy of dx, or your implicit differentiation of, yes, that exactly. So yeah, it just look in the solution. It's exactly the same. I suck at talking. All right, there you have it. That's 5.4. Let's move on to 5.5. 5.5 is basically the same idea, but now you're just doing two things. All right, so implicit differentiation formula number 2 is this right here. So let me actually draw in black, because just to make it organized. All right. For 5.5, right? This is 5.5. Yeah. All right, so we're given the equation x squared z cubed plus y squared minus z squared plus 6yz, and it was equal to 10, but I'm just going to move 10 to the left side already. So all I did from that original equation is just move the 10 to the left side, so it's with the rest of the variables. All right, so before we do any like f of x or f of y, implicit differentiation formula number 2 is basically saying you have to find your partial derivative of your x and your partial derivative of, I'm sorry, your partial derivative of z with respect to x and with respect to y. All right, to do that, remember that you have to find let me actually write this real quick. Your partial derivative of z with respect to x is also equal to, that's actually an equal sign, not a z, is actually equal to, I should have wrote this earlier, your negative f of x over your f of z, okay? And then your partial derivative to z with respect to y is going to be negative f of y over f of z. So this is something you got to keep in mind. This is the implicit differentiation formula for 2, or implicit differentiation formula 2 for 5.5. Remember that your partial derivative of z with respect to x is also equivalent to this, and your partial derivative of z with respect to y is also equivalent to this as well. That's a z. That's a z right there. And that's also a z right there. Okay. So all we're doing right now is just finding your f of x, your f of y, and then your f of z, and then you're just going to be plug and play, easy plug and play. So your f of x is just taking the derivative of x of your equation that we have up here, right here. Underlined it in red. Is this going to be x of, you know what, fucking, all right, oops, sorry, my bad. This is a friendly environment, not an SI, so you know what? I don't have any restrictions on me. All right, so here we go. So this is gonna be, with respect to x, is gonna be 2x z cubed, right? This is gonna be 0 because there's no x value. This is gonna be 0, there's no x value. This is gonna be 0, there's no x value. And this is gonna be 0 because it's constant. So all you're gonna have right here is this 2x z cubed. Alrighty, now let's do with respect to y now. So d of dy, your derivative of y, and then let me just do red just to make it all seem organized, z cubed. I know I'm being repetitive here, but I'm pretty sure Professor Noring said something about, being repetitive, because it ensures that you're gonna get the right answer. So I know that I'm writing this equation down, but I suggest you do it as well because it's a good habit to have. All right, so now we're doing respect to y. There's no y values here, so that's 0. There's a y value here, so that'll be 2y, okay? There's no y values here, that'll be 0. And there's a y value here, so it'll just be plus 6z. And there's no y value here because that's a constant, all right? Now we're gonna do the last one, which is f of z, so d of dz. Like I said, I'm gonna be repetitive, but that's what Professor Noring wants, and he still hasn't graded our Unit 3 exam and Unit 4 exam, and it's been like 3 weeks already. So, okay. Minus 10. Nice. All right, so with respect to z this time, this is z value here. I just got an email. Hopefully that wasn't important. Oops, made a mistake. I'm going to write x first here. X squared z squared. Okay, because you take the 3 out, and this 3 minus 1 is 2, so 3x squared z squared. All right, this becomes 0 because there's no z value. There's a z value here, so it'll be minus 2z, okay, plus 6z. Right? Let me make sure that I'm doing everything right. Oh, I'm stupid. I'm so stupid. That's actually plus 6y, right? Because there's a z value here that becomes 1. It'll just be plus 6y. All right, so we have all our f of x, f of y, and f of z. This is your f of This is your f of x, f of x. This is your f of y, and this is your f of z. Nice. So like I said, this is just going to be easy plug and play, because like in the question, it says find your partial derivative of z with respect to x and your partial derivative of z with respect to y, which is these two things right here. And as you can see, all we got to do is just plug in your f of x and your f of z into both of these equations. So let's do it. I'm going to clear this in like 2 seconds. 1, 2. Hopefully y'all got it. All right, clearing. So going back, d of z with respect, oh God, or with respect to x, right, is negative f of x over f of z. And we already have our f of x, which this is going to be negative 2x z cubed over this is your oh God, I'm saying so this is oops, oh goodness gracious, this is going to be your f of z value, which is right here. Okay, alrighty, 2z plus 6y. So hopefully y'all can read that. This is your partial derivative of z with respect to x. It is negative 2x z cubed over 3x squared z squared minus 2z plus 6y. And that is the answer for the first part, which is the partial derivative of z with respect to x. And remember where I got these values from is from solving. So hopefully if you just go back like 20 seconds to where you saw my drawings before I cleared it, that's where I got these values from. And that negative is just a part of the equation or the formula. All right, now let's do y this time. Partial derivative of z with respect to y. It's just going to be negative f of y over f of z. I'm going to try to get the second one out as soon as possible too, so y'all can not feel lost about this exam, you know? So this is going to be negative because, like we said, and your f of y value is 2y plus 6z over 3x squared z squared minus 2z plus 6y. I mean, yeah. Is that the answer? Yes, it is. So there you have it. Your partial derivative of x and your partial derivative of y are these two values right here. Let me just circle all of them in black so you know. And these are the two answers. Hopefully these were helpful. I apologize if you still are confused. I did my best. I just wanted to release something so y'all aren't completely lost, because I have people DM me that they were confused. So you know what? Here you go, guys. And hopefully y'all understand the first part of the exam. I will try to do the next exam soon. So yeah. All right, guys. Thank you for watching.